All right, what I want to do now is finish up the basics of bonds, and maybe later this week we'll finish up bonds completely and get into some interesting topics that you might have seen before in an accounting or a finance course, like BACC 211, I think, or 221, or BFIN 300. That's internal rate of returns, net present value, things like that. All right, so I want to do an example that is similar to 1.7 in the book, homework that I'll assign. So let's say we have a $5,000 bond that matures in 10 years. The bond interest rate, same thing as the coupon rate, is 5%, 6% yield rate. Okay. So you immediately reinvest coupons in a fund earning 4% semi-annual nominal interest. You take a loan out to pay for the bond. Payments for the loan are constant at the end of each year, and the loan interest rate is 3%. Calculate the net profit after 10 years. So what do I mean by net profit? It's what you would usually think as a net profit, or just the profit from this investment scheme. So you just add up, you figure out at the end of 10 years how much you made, and then subtract all of your payments, not time valued, and that's your net profit. And it's going to be the same thing for 4.1.7. So you're just taking the accumulated value at the end of 10 years minus all of your payments, and that's your net profit. Okay, so first of all, I just want to remind you of the formula we're going to use to price this bond. The easiest thing to do is McCamm's formula. Take F times the present value factor, get K, and the price is K R over J, F minus K. F is the face amount, R is the effective per period coupon rate, J is the effective per period coupon rate, unless otherwise stated. It's the periods are every 6 months, and we don't state anything, so that's what we're assuming in this problem. And we're assuming the rates given, or the coupon rate and the yield rates given, unless otherwise stated, they're semi-annual nominal interest rates. Nothing is stated. So we're going to assume it's semi-annual nominal interest rates, both the coupon rate, interest rate, same thing, and the yield rate. All right, so let's figure out what the bond price is. Since the coupon rate is 6% semi-annual nominal, the per 6 month effective coupon rate is 3%. 0.06 or 6% over 2 is 0.03, 3%. All right, and there's 26-month periods in 10 years. So K, the formula for K is the face value, 5,000, times 1 over 1 plus J to the 20th. So that's 2768.38. All right, so the quoted coupon rate is 5%, interest rate, same thing. And again, we don't state anything, so we're assuming that is the nominal semi-annual rate. So 5% over 2 is the 6-month effective rate, effective yield rate. That's 2.5%. So, sorry, that's the coupon rate. The yield rate is 6%. The coupon rate is 5% nominal semi-annual divided by 2, 2.5% coupon rate. The interest rate, the yield rate rather, we said is 3% divided by 6% divided by 2.03. So R over J is 0.025 over 0.03 times F minus K. So just dump this in your calculator and you get 4628.06. Okay, so this is how much you need to take out to pay for your bond. Okay, now let's say K is the loan payments for this loan of $46.28 and 6 cents. So maybe I could have used something else, but let's just say now K is the constant loan payments like we've been doing before. All right, so it's a 10-year loan, 3% effective annual interest, payments are K. The loan amount is $46.28 and 6 cents, which is the same thing as present value. So dump into your calculator for the payment, $542.55. So the total amount of loan payments you're making, non-time value, is $542.55 times 10 is $5,425.50. Okay, so what's the accumulated value in the fund after 10 years? Well, remember that you're making coupon payments into this fund of F times R. Okay, and again, R is the bond coupon interest rate, same thing. This is semi-annual nominal rate, so divide by 2.5% is the coupon rate, or 0.025. So the coupons each 6 months is F times R, 5,000 is F, R is 0.025. So at the end of each 6-month period, you're depositing rather 5,000 times 0.025. All right, well, there's 26-month periods because you're doing this for this 10-year bond. And nominal semi-annual interest rate for the fund is 4%. So divide by 2, you get 2% as an effective 6-month interest rate for this account. So the accumulated value of all these coupon payments is 5,000.025, S20, your effective 6-month fund rate, 2%. So this becomes $3,037.17. So your net profit is going to be this amount, how much you have in the fund at the end of 10 years, plus 5,000, you get your face value back, minus the total amount of money you've paid to get rid of, to pay off this loan. So the total profit you've made from the scheme, not time valued, is $2611.67. Okay.
All right, what I want to talk about now is what happens when you have coupon rate is bigger than the yield rate versus equal versus less than. And this gets into some very, very practical finance and financial terms. All right, so remember, if we have all this information, then in particular, Maycham's formula gives me the price. Okay. And one thing we could do absolutely trivially is essentially do a little factoring. Okay. So if you just distribute this out, this here times this, you'll get this. It's literally just algebra. But this actually tells me something pretty important. And what does that tell? Well, besides just telling me the price is this, let me pop this up and explain what this tells me. So all I'm going to do is take this here. Yeah, I'm going to take this here and subtract off the price. Annoying. Okay, so what we have is price minus face value is going to be This whole thing, this times this. So R over J minus 1 times F minus. All right, and what good is this? Well, so one thing I want to make clear, remember that K is F Vj to the n, so 1 over 1 plus j to the n. And that's always going to be, as long as we have a positive interest rate, which we always do, basically, in exam FM, this is always going to be less than f. Cares? Well, I care because we know this is going to be positive. So whether this is positive or negative only depends on whether this is positive or negative, because this is always positive. And what we're interested in particular is how the price compares to the face value, and what the relationship is between the price and face value, depending on the situations. The coupon rate is bigger than the yield rate, equal, or less. So in particular, R bigger than J is exactly the same thing as saying this is positive. So this and these kind of weird arrows means this means precisely when. If you've taken the proofs course, it's if and only if, but in plain English, it's exactly, precisely when. So R is bigger than J precisely when P is bigger than X. Why? Well, R is bigger than J precisely when this is positive. That's what I mean by this here. And there's really nothing. R bigger than J means R over J is bigger than 1. And that means this is positive. This is always positive. So basically we have that this being positive is true precisely when this is positive. And that's precisely true when R is bigger than this. On the other hand, because this is always positive, the only way for P minus F to be negative is, equal, not negative, equal is if this equals 1. That equals 1, R over J equals 1, so that this whole thing equals 0. The whole thing equals 0 precisely when R over J is 1, which is the same thing as saying R equals J. So R over J minus 1 equals 0 is the exact same thing as saying R equals J. So the price equals the face value precisely when R equals J. And same thing here. It's not a big deal if what I'm doing doesn't make sense, but it really should. I'm not doing a whole hell of a lot. And it's pretty remarkable. And remember, even Maycham's formula is just trivial algebra. So really just trivial algebra gives us this pretty important finance conclusion that we've derived very carefully. I'm always amazed that like little trivial baby math actually tells you something useful. Or I'm amazed when baby math, trivial math, tells you something very useful. Right. So because this is positive, the only way we get P minus F to be negative, or rather P minus F is negative precisely when this is negative. This is negative precisely when R over J is less than 1, which is the same thing as saying R is less than J. So the conclusion here is R is less than J precisely when P is less than Okay, so if one is true that we say the bond is bought at a premium, and to be clear, when I say we, this is very generic financial terminology. The actuarial science, accounting, finance, whatever. This is universal terminology. If you've ever played golf, you probably know that par is like okay, I guess, an okay score. So this is neither good nor bad, I guess. I don't know. I mean, 1 or 3 is neither good nor bad, but this is par means it's like, oh, it's sort of like in golf. It's a little weird, but so we say if 2 is true, then the bond is bought at par. Same thing as saying R equals J. And 3 is true if the bond is bought at a discount. And if 1 is true, P minus F is the bond premium. If 3 is true, F minus P, just to give us something positive, is the bond discount. All right, so let's just do a quick example, getting the bond discount. The one thing, be clear here, so here, the rate is less than the coupon rate, same thing as the interest rate, is less than the yield rate, and therefore the price is less than the face value, which for this table is set at $100. So that exactly confirms this conclusion right here. R is less than J precisely when the price is less than face value. Right. So let's use this formula here to quickly double check and get the bond discount, or check that it's true. Okay, so let's get K first. So 3,224 over 2, store that in the 2 spot, get the interest rate, yield rate, get that coupon rate, 0.03125, 2, store that in the 1 spot. All right, so what is K? 100 times 1 plus 2 to the minus 60. Store it in 3 spot. All right, so right. So that's what K is. So I'm going to take 100 minus K times R over J minus 1. Right. And this is literally what P minus F is. So F minus P is going to be $1.89. Let me store that in a 4 spot. Let's just double check that. So 100 minus the price, 98, 10564. One second, we'll check that again. 100 minus 98, 10560. Yeah, they coincide. This is actually probably a little more accurate because calculator is set to do 9 digits. But yeah, 1.89436. So little brain fart there. Got a little worried that it didn't coincide. 1.89436.
Okay, let's do an example, and this is similar to 4.1.4 and 4.2.6. Okay. So this is a problem about taxing bonds, and so this problem is a little bit unrealistic. We'll talk about how in real life, particularly when you buy corporate bonds, how bonds are actually taxed. Unfortunately, it's fairly complicated. Or fortunately, if you're planning on being an accountant, yeah. But anyway, so we have a 20-year bond, 5,000 face value, 6% effective annual coupon rate. That pays yearly coupons. You pay a 3% tax at the end of each year on the year's coupon, and pay a 7% tax at the end of the 10 years on the amount of discount the bond was bought at. Find the price of the bond if the purchaser wishes to realize an 8% effective annual yield. So what does that even mean? We've done that before, but I want to just explain what this means. And if you've seen internal rate of returns, we'll get into that later, but if you've seen it, it means your internal rate of return is 8%. Okay, well, what the hell does that mean? That means that, so this problem, we have cash in, we have cash out. The cash you're getting in is the coupons and the face value at the end of 20 years. The cash out that you're paying is the tax on each coupon and the tax on the discount that the bond was bought at. Okay? So we're saying that you're willing to pay the present value of all the cash in and cash out at 8% effective annual interest rate. That is exactly what it means to have an 8% annual yield. Again, you're willing to pay the present value of all your cash in and cash out at a rate of 8%. That's exactly what it means to have an 8% yield. Okay, so let's do this problem here. So let's say P is the bond price. So we can't just willy-nilly use our bond formula because, well, the bond formula does not take into account the fact that you pay a tax on the bond, but that's okay because the bond formula is just present value of all your, the present value of everything. And that's what we said the bond price is, and this is no different. So we're going to take the present value of everything. Okay, so first of all, what's the yearly coupons? Well, it's 5,000, your face value, times 0.06, your effective annual coupon rate. And again, as I mentioned, unless otherwise stated, coupons are every 6 months, and the coupon rate is nominal semi-annual. Well, here, I am telling you otherwise. I am telling you it's an annual rate, the coupon rate, interest rate, same thing. Bond interest rate and coupon rate are the same things. And we have yearly coupons. All right, so F times R, F your face value, R your effective per period coupon rate. It's just 5,000 times 0.06, which is 300. Okay, so you pay a 3% tax on this 300 every year. So your after-tax amount you're getting at the end of each year is 291. 300 minus 300.03 is 300 minus 9, 291. So the timeline is as follows. You're getting at the end of each year 291. Those are your after-tax payments from the coupons. You're getting your face value back at maturity, which is at the end of 20 years. So that's 5,000. Okay, but you still have to pay 7% on the discount. So you have to pay 7% on the amount of discount that the bond was bought at. Well, we know what that is. The bond discount is F minus P. Okay? So the tricky thing is, it's not that tricky, but you don't know what P is. We know what F is, 5,000. We don't know what P is, but that's okay. So it's 7% of F minus P, which is 0.07, 5,000 minus P. And it's negative because you have to pay it. Okay. So again, we're willing to pay the present value of all this at 8%. So then the bond price is exactly the present value of all these payments, of all the cash in and the cash out. The only cash out is this tax on the discount of the bond. So the present value of all this is 291,820.08. That's the present value of all these after-tax coupon payments. You got to discount 5,000 by 20 years at 8%. And you have to discount minus 0.07, 5,000 minus P by 20 years at 8%. And you do all that, you're going to get these three values plus 0.015P. So we just bring P to the left-hand side and add these three up. We get 0.985P is 3854.73. Divide by 0.985 and we get 3913.43. Okay. So again, nothing too bad in this problem. It's just the present value of everything here. The coupon, after-tax coupon payments to you, 5,000 face value payment to you, and then the payment you have to make of 7% of the discount that the bond was bought at. So you take the present value of all that at 8%. That's how much you're willing to pay for the bond. So the bond purchase is the present value of all this at 8%, which is this. Then you solve for P. Okay.
Okay, something important to note for exam FM in particular, you sometimes don't have redemption value being face value. Okay? And typically we call the redemption value C. I guess it would make more sense to call it R, but that's just not what standard actuarial terminology is. But still, we're going to have F, and F is going to be used to compute coupons in the sense of coupons are just F times R, like we've done before in the previous video. So the price is no different, really. You take the present value of your N coupons at my yield rate J and discount the redemption back to 0. And again, remember, what is J? Well, Vj is 1 over 1 plus J, and then raise it to the N. So, right, this is just discounting by N periods. And F is, for some odd reason, sometimes called, or it's referred to usually as a par value when C is not equal to F. It's a little strange, but I guess it is what it is. And there is a version of Maykamp's formula. It's a little more complicated, but particularly if you look at like Coaching Actuaries or another study guide, the Infinite Actuary, whatever, you will probably see this. It is questionable how useful it is in practice, but if you want to use it, use it. No, I just want to, because a lot of the study guides use it. So, and here, G is FR over C, K is the present value of redemption. Let me just show you where this comes from. Again, look like it's absolute magic. Save. Okay, yeah, it's really baby algebra. Price is do the same thing that we did before. We'll skip over this, do that. So FR one minus VJ N. Just write out what FR A and J is. Then over J. C V J N. Yeah, we can talk about using Maycham's formula. I would suppose maybe the use of Maycham's formula is to allow us, in theory, to very easily talk about par, discount, and premium when dealing with bonds with redemption value is not the case. But anyway, so what I'm going to do is as simple as multiply and divide by C. So here's what I'm going to do. I'm going to literally move this a little bit. Okay. A little bit more. Okay, so I'll put this in. So yeah, I'll use well, put this in parentheses. And I'm going to divide by C. Sorry if you heard that ding. And then multiply by C. Typesetting is harder than the actual results. Right, and this is a reasonable thing to do. Why? Because remember this is G. Sorry, G is FR over C. So also, right, as I did before, I'm going to just move the J here. Not doing a whole lot. Literally move it, still in the denominator. Right, so what is this? Well, this is just, remember G is FR over C. So this right here. See? Yeah, like I said, if you don't want to go through this, you don't have to. I always just like to see where things come from. I'm a math person. If anything, it makes I can memorize formulas more easily if I see where they come from. Hey, weird like that. The only one who's weird, maybe. If anything, I'm not wasting too much of it. Yeah, so what is this? This is G over J. Distribute to C. C minus C V J N plus C V J. Not sure. Yeah, as before with Maycham's formula, this is really, really trivial. This is just baby like arithmetic. Yeah, I can't even call it algebra. Arithmetic. But yeah, like before, this is K. K. So I'm not going to write anything more. It's G over J, C minus K plus K. G over J, C minus K plus 1. Simple as that. All right, and just like before, you literally distribute this here. You can see that we will get K plus G over J, C minus K. I'm not even going to do it because literally just distribute and see it. In particular, the one term, if you take G over J times this whole thing, you're going to get G over J, C minus K, and you want a K here. Well, you have this C, and then you do minus C minus K is going to be C minus C plus K, which is just K. So you get K plus G over J, C minus K. You just distribute this. Well, this gives us exactly when the price is bigger than redemption, equal to redemption, or less than redemption. It's exactly what I did before. You can go through it yourself if you'd like. Except instead of R over J, we have G over J. And like before, K is C Vj to the n. That's always less than C. So this is always positive. So P minus C is positive precisely when this is positive. P minus C is negative precisely when this is negative. And P equals C precisely when this equals 0. Same thing as G. Okay, same terminology. If the price equals redemption, bond is bought at a premium, and P minus C is the bond premium. If the price is less than the redemption, so I think for one, I said if the price is bigger than redemption, the bond is bought at a premium. 10 o'clock at night on Saturday, you hopefully saying stupid, and I'm tired from deadlifting. Yeah, and if P is less than C, the price is less than redemption, then C minus P is the amount of discount the bond is bought at. And if the price equals the redemption, bond is bought at. Okay, yeah, so as a sanity check, let's find the price of this 10-year bond using both Makeham's formula and both with and without, and check that it works out, and verify the conclusion from the previous slide. In particular, compute J. Well, sorry, there's really nothing to do with computing J, but compute G, compare it to J, and see which one is true, and just verify this example. One thing's clear here, you can't just literally look at these problems and be like, oh yeah, clearly it's bought at a premium, bought at a discount. You really just have to compute G and compare it to J. There's no other way. Okay, so let us do that. Yeah. Thanks. We'll do that later. Thanks. All right, so I guess let's do Makeham's formula first. I don't know if this is any easier, but again, if you want to use it, use it. So R is R2 over 2, and as usual, I'm doing this with Makeham's formula, I need these rates in decimal form, so 0.01. J is, well, 3%, 0.015. A lot of stuff here. F is 110. Yeah. Right. C is 100. N is 20, 10 years. Remember, unless otherwise stated, semi-annual coupons. All right, so here's everything we need. All right, so let's get G, F is G, FR over C. So it's 0.01, that's, oh, sorry, 110, that's F, R, 0.01 over C, 100, just plop this into the calculator, 110 times 0.01 over 100. Might as well store that. 0.011. Let's get K. So I'm not going to store R and J because they're simple here. If they were more complicated, I would. I think usually Exam FM gives you pretty straightforward rates or pretty easy rates, not very long. Store them. I think I stored this in the one spot. Sure. Okay, what's K? Redemption C times 1.015. Discount redemption using the yield rate by 26-month periods. All right, so let's now go to McCabe's formula. So let's G over J, C minus K plus K. Oh, okay, I already got K here, so it's good. Plus we call 1, that's G over J, 0.015 times parentheses C 100 minus K 93, 13, 25. Yeah, I mean, I have to admit, it's actually going to be a lot quicker using the calculator. And we'll see in the next video how to do it even quicker than the way I'm going to do it with the calculator. So yeah, some people, if you go to like Reddit forums and stuff where actuary exam FM is discussed, some people say Maycam's formula is pointless. I'm mainly going to do it just because a lot of people use it. A lot of study guides use it. TIA, the Infinite Actuary, coaching actuaries, they use it. So, okay. Was a great thing. Okay. So I'm not going to store. Well, I guess. All right. So yeah, let's get our. I mean, you can. I'll just use the formula here. But one thing I want to emphasize, I don't memorize this formula. There's no point. I memorize how a bond works, so I know to just to take the present value of my FR, my coupons, FR A and J, discount, take the present value rather of my redemption. That I remember, but just remember the time diagram. But I don't really have this formula. But anyway, so FR par value is 110. So 110 times 0.02 over 2. So it's 1.1 are my payments, 20N. My yield rate is 3% over 2. Compute present value. And now all I do is discount 100 by 20 years. 5. And lo and behold, not sure what happened to everything down, but anyway, yeah, it's oh, there it is. Yeah, 93.1325, 93.132. So yeah, and compare this to what I stored in the one spot. It's literally the same. Because it's literally the same, it's not. Okay, right, last but not least, so take 100 minus this, $6.87 cents. Two spot. So yeah, sorry, I don't really want to verify what the amount of premium the bond, or sorry, so the bond is bought at a discount. I don't want to verify the amount of discount the bond is bought at, but I do want to at least verify. So the price is $93.13. Redemption is 100, so price is less than redemption. So we have to have G is less than J, and let us double check that. Actually, I think I stored G. Also, I don't need to store G. It's silly. This is G. This is J. So G is not much smaller than J, but it is smaller than J. That has to be true because the price is less than redemption. Price is less than redemption. So that checks it. Checks as a sanity check that in this case the price is less than redemption. And as has to be true, G is less than mind you.
Problem, and not to scare anyone, but this is honestly the first problem in the ASM Exam FM study guide. I do recommend that study guide very much. Most people recommend it. But anyway, so you've decided to invest in two bonds. Bond X is an N-year bond with semi-annual coupons. Bond Y is a zero coupon bond, which is redeemable in N over 2 years. Implicitly, N is even in this problem. Otherwise, N over 2 years doesn't really make sense. Doesn't matter, really. So the desired yield rate is the same for both bonds. You also have this mess of information here that the par value, face value of bond X is 1,000. The ratio of the semi-annual bond rate to the desired semi-annual yield rate is R over I. Or sorry, which is R over I. So R is the effective semi-annual bond rate, and I is the effective semi-annual yield rate. I like to use J. Again, I like to reserve I for effective annual interest, but they're using I, so their I is our J. We're saying R over I is 1.03125. Present value of the redemption value, which is the C that I just mentioned, which is not the face value of this problem, is 381.50. On the other hand, the redemption value is the same for bond Y as it is for bond X, and the price to yield is 647.80. So that's just saying the price of bond Y is $647.80. What is the price of bond X? All right, so let's look at this mess of a problem. So let's work with the easy situation, and that is bond Y. Okay, so So bond Y is a zero coupon bond. The price is $647.80. Okay, and it has the same redemption value as that of bond X. Let's say C is the redemption value for bond X. Okay. And it's also redemption value for bond Y. So what's going on is bond Y, remember, pays no coupons. So at the end of n semi-annual periods, because bond Y matures in n over 2 years, so you have 2 times n over 2 is n semi-annual periods. Okay? So after n semi-annual periods, you get C back, but you get nothing else. So how do you figure out what you price that at? Well, you just take the present value of C. Okay. If you pay something to get C in n periods, you take the present value of C to figure out what you're willing to pay for that. Okay. That's something we've done a million times. Okay, and we're given that the price of this zero coupon bond is $647.80. So C 1 over 1 plus I to the n is the present value, which is the price of bond. Okay, and they have the same yield rates. Okay, so that's why we're using I here. Okay. So this means that C is $647.80, and I'm going to plug that into the price formula for bond X. So actually, before I do that, we're given that the present value of the redemption value is $381.50 for bond X. So what that means is, all I'm doing is I'm taking the present value of the C here. Oops, sorry about that. Now here it's a little complicated, or a little annoying, I'd say, not really complicated, but this is an end year bond. So we have 2n semi-annual periods. So I take my C and I discount it by 2n semi-annual periods to get the present value of the redemption value. Okay? So that is $381.50. We're given that, and we just take our C discounted by 2n semi-annual periods because it's an n-year bond. Well, now I'm going to plug this in to what we have here. So it's $647.80, 1 plus I to the n, times 1 over 1 plus I to the 2n gives you $647.80, 1 over 1 plus I to the n. Okay. So now I can solve for 1 plus 1 over I to the n by just simply taking this number here, dividing by 647.80. Okay. Now I'm going to plug this into my bond price formula. So let's say P is the price of bond X. Okay. So the coupons are still F times R. F is 1,000 because it's a $1,000, sorry, it's a 1,000 face value bond. Par value is 1,000, same as face value. So it's F times R. Okay. There's, again, 2n semi-annual payments, so it's A2n, J is the yield rate for the bond, the effective semi-annual yield rate. So it's F times R times A2n, J. You discount the redemption value by the number of semi-annual periods, which is 2n. All right. So actually, we know this is $381.50. So this here is 381.50. Now let's just recall the formula, and we had it actually right here. 1 minus nu j to the n, the present value factor over j, if you forgot it. Whoops, sorry about that. Okay, so here, and sorry, this should be an I here. It's A 2n I. So it's 1 minus 1 over 1 plus I to the 2n over I. Again, it should be I, our present value, our yield rate is I, not J. Okay, so, well, we know what R over I is. We're given R over I. It is 1.03125. We know what 1 minus 1 over 1 plus I to the 2n is. It's whatever this is. Well, sorry, it's not whatever this is. It's 0.5889. That is what 1 over 1 plus I to the n is. Square it to get 1 over 1 plus I to the 2n. And you square 0.889, you get 0.3468 after rounding. Okay? And then you dump all this in, you get 10.55 and 11 cents after rounding. And the book has it as 10.55, so we're only off by 11 cents, and that's absolutely acceptable. Okay. So again, the punchline here is we're actually plugging in. You can't just plug into the calculator because you don't know what n is. You don't know what I is. Again, this should be there should be an I here. Okay, but if you just plug into your formula, you're going to get an R. Actually, sorry, you don't know what R is, what I is, or what n is. But you do know what R over I is. You know what 1 over 1 plus I to the 2n is. It's just square both sides. 1 over 1 plus I to the 2n is 0.5889 squared, 0.3468. So you can plug all that in. R over I, 1.03125. 1 minus 1 over 1 plus I to the 2n, 0.3468, plus 381.50, which is again, C 1 over 1 plus I to the 2n. And now you just easily throw into your calculator and you get 10.55 and 11 cents. So yeah, really twisted, convoluted, silly problem, but just remember I don't write the exam FMs, so if you think these problems are ridiculous, these FM problems, well, not a whole hell of a lot you can do besides just get a study guide and practice, practice, practice. Do as many problems as you can absolutely possibly do. Anyway, so yeah, it's the end of the basics of bonds, and we will talk about two more topics in bonds, buying and selling bonds, outside of a 6-month period, which is a little tricky, but and then amortizing a bond, which, as I mentioned, is extremely important for accounting purposes when you actually pay tax on a bond that you bought. Or yeah. All right, so long, stay safe, and I'll give you another video maybe next few days, and you will get your exams back within the week, hopefully. It takes a little bit of time to grade them, so, especially it's a little awkward just grading them, with just on the computer. I don't print them out, so anyway, take care. Until I see you again.